Hi, I'm Brianna Hansen. For my CNIT 176 final project, I turned my Raspberry Pi into a security camera with cloud storage. So, what's the purpose and relevance of my project? Well, almost all homeowners these days have some sort of security system, and the demand for these systems will only continue to grow. But according to a 2024 article from Angie, the average cost of installing a security camera is over $1,000. So, making your own cloud-based security camera with a Raspberry Pi is much more efficient, and this also gives you hands-on experience with important computer architecture concepts such as networking, operating systems, and file storage. In addition, cloud storage is much safer than just having videos saved to the physical device. With cloud storage, if it gets lost or broken, you still have access to that video history. So overall, this project has helped me build technical skills, troubleshooting skills, and problem-solving skills that I can use in future IT and cybersecurity roles and courses. So now we're going to move on to the Raspberry Pi architecture. So I use several input-output peripherals in my project. The most common or the most important one was the USB camera that I connected to the Raspberry Pi to capture the video. So during setup, I also used a keyboard, mouse, and monitor to interact with the Pi directly before setting up remote access. And then once configured, the camera acted as an input device and I could view the output through the MotionEye web interface. And then the operating system is the foundation of this whole project. So I updated the Raspberry Pi operating system and I worked with the Linux-based file system. So I had to create directories for saving the video footage and adjust permissions so that the MotionEye could access and write to them and connect cloud storage to automatically upload files. So these steps really helped me understand the relationship between operating systems, file systems, and how applications depend on them. Networking was also a really essential concept that I used in this project. So I had to connect the Raspberry Pi to Wi-Fi so that I could access the MotionEye interface from other devices. And then once it was online, I configured it to the video to upload videos files directly to the cloud, which that also taught me how client server networks works. So the Pi is the client sending the data to a cloud-based server like Google Drive. And then the Raspberry Pi CPU and memory were put to use constantly in this project. So the CPU processed real-time video and handled motion detection through that MotionEye package. And then the RAM was used to buffer video files before uploading them to the cloud. And one thing I noticed was that if too many services ran at once, the Pi would slow down or overheat. So that kind of taught me a lot about how system resource limits and how to manage that. And then also, the motion detection in my camera was based on Boolean logic. So the software makes a yes or no decision, like did the motion occur or did it not? And then based on that logic, it either starts recording or it will stay idle. So this was a really good way of kind of having that real world application of the logic gates that we talked about in class. Um, so yeah, that's kind of my Raspberry Pi architecture part. Now moving on to my procedures. I first installed the Raspberry Pi, um, or I updated the systems for my Raspberry Pi. And then I installed the MotionEye package, which is the software that lets my Pi kind of act like that security camera. And I also connected my USB camera and then tested that the video feed was working. And then I installed a tool called rclone that lets you sync files to cloud storage. In this case, I use Google Drive. So I linked my Google Drive account and set up the folder on my Raspberry Pi where the MotionEye stores the recordings. And finally, I tested it to make sure that the video was saved locally and was also uploaded to my Google Drive automatically. So in this section, I'm going to show you the final results of my project. So first, you can see me running this command and showing you that I'm selecting that Google Drive um, as where I want my videos saved in the rclone. And then this was already configured earlier, so it kind of confirms that my connection was successful to our clone. And then you can also see in my Motion Eye files on my Pi that there's a video that was recorded in one of my earlier tests to kind of test that that motion detection was working. And then you can also see that video um, is the one that I linked to my Google Drive using that R clone. So here I'm switching over to my Google Drive, and then you can see that same video file is right there. So this proves that the cloud upload does work, and even if something happens to the physical device, the video footage is safely stored online. So right here you can see it detects me walking in front of the camera, and yeah, so that was the test video that I took. Um, and yeah, so now on to troubleshooting. So I ran into a few issues while working with this project. Um, at first, the Raspberry Pi didn't really detect my USB camera, but I fixed this by switching USB ports. And then I also had a lot of actually file permission errors when I was trying to install MotionEye. And when MotionEye tried to write video files, I also came across some errors. So I solved this by changing folder permissions in the terminal, and setting up the R clone with Google Drive was also a little bit tricky, but after redoing the authentication, it worked. And I learned that I had to restart the MotionEye service if I wanted to make changes, or else they wouldn't take effect. So a lot of my troubleshooting was kind of having to create new directories and granting new permissions so that I could, get my my installations up and working. And yeah, so on to the next part. The lessons that I learned from this um, were quite a few. So through this project, I learned a lot about how a Linux-based operating system works. So I got a lot of hands-on practice installing the software, using the terminal, and navigating file systems. So setting up rclone also helped me understand how to securely connect devices to cloud services. And most of all, I learned how to troubleshoot issues like fixing those permission errors and dealing with camera detection problems. So these skills will definitely help me in future IT and cybersecurity courses. Thank you so much.